how long you takes the running simulation? Around 1 month, yeah, in your simulation within the time step 10 minutes. And the second is what device that you use to simulate your simulation.
So what's the last part?
Device, especially computer specification you use to simulate the.
Oh, okay.
Is this your simulation expensive?
Okay, yeah. So I think most of our simulations are for 1 month, but there are some simulations which are even shorter. If we didn't need longer simulations, we can do it for 10 days or 15 days and things like that. And all the simulations, we run it at NCAR, which is the National Center for Atmospheric Research, which actually has a huge supercomputing, and we run it. So I would say with 12 kilometer resolution over the entire maritime continent, 1 month of simulation takes, I know the exact time, I think it takes about 16 hours. 16 hours of actual time. Now that number varies depending on how how many CPUs are available in that supercomputing center. So I think, so I think in general, the amount that are available, it takes about 16 hours to run for 1 month with 12 kilometer. And of course, another really important factor is the vertical resolution. Correct? So if you have 40 layers versus 80 layers, the timing will be double, for example.
Maybe I have the next question about the grid, because I usually I never simulate in the large system. I am in the small system. Actually, I have some problem with the grid in the X and Y. Do you have any experience about the grid in the large system? Have the blow up in the simulation, or?
Yeah, so I think what you are asking is how grid size may impact the stability of the model, correct? Stability of the model. So which model are you using?
What model?
I'm using the zero water and also the partial differential equation.
Simple hydrodynamic.
So simple hydrodynamic equation. So it's for simple hydrodynamic equations, it's hard to tell unless you actually use it. So unless I use your model, it's hard to tell, exactly what is happening. But I think one conservative step that you can take is basically choose a very small time step and see whether it works. And so you have to play around a little bit in terms of your delta X and delta Y and delta T. Now, I'm using WRF, which is the Weather Research and Forecasting Model, which is very, very well used. So you do not have to try anything. It's already given, what should work and what should not work. So for us, it's actually very simple work.
In my experience in Indonesia, mostly more technical problem with the computer configuration, like the kernel is not enough, whatever it is.
So I think, coming back to your earlier questions, running models generally should not be too difficult in terms of computational power. So at least in the US, the real difficulty has been the storage of data because it's so expensive to store data. Although the cost has reduced, but in our case, for example, we run it in NCAR. Let's say the output is, let's say, 10 terabyte. So the real trouble is to bring the data set to us, and that takes more time than running the model.
Yeah, in Indonesia, mostly, especially university, that's a big problem because we don't have, I don't know in UNPAD if we have high performance computer or something like that. Yeah, we don't have, that's the problem.
Yeah, so I think one way to handle that, so this was a similar situation in India like 20 years back, that universities did not have much computing power. So what India has done now is they have built up 2 large supercomputing centers. One is in Pune, which is called Indian Institute of Tropical Meteorology, and the other one is in Delhi, which is related to weather agencies. So now any university student or faculty can log into those computers and run it and basically keep that data set. So I think those of you who are in administration, like Fadli or the dean, I mean, I do not see a reason to do that at the university level. It will be very expensive for a university to do it. It should be done probably somewhere in Brain or one organization where everybody can log in and work.
Yeah. Brain.
You have it in Brain, okay.
But I should ask the dean to ask for the Ministry of Education, the dictiva, please. That's good for idea, but just asking a proposal or something like that. Okay, thank you. Is there any? This is a lecture, so you can ask any time. After, yeah. Pak Noy.
Yeah, thank you, Prof. Kumar. Thank you, Prof. Adli. Yeah, I agree with Prof. Adli that this is very interesting finding for me, because I'm also not really know about the meteorologists in Indonesia. Maybe I missed your presentation, Prof. Kumar, about your scenario about removing Sumatra alone, Papua alone, but you remove Kalimantan and Sulawesi, both of that. Why is that?
Yes, that's a good question. So that's mainly because of the location of Sulawesi. So we could just remove Borneo, but what was happening is it was going through some of the middle of other islands, so which we didn't want to do it. So it was much easier to include Sulawesi and remove the whole island. So there is really no scientific reason, but it's mostly for numerical reason, modeling reasons.
Okay, thank you. So the second, I don't know if this is a question or not. In Indonesia, we have like 17 islands, 70,000 islands. 17,000, yes. And we already like sinking like 250 islands from 2005. But your finding is the size of the island is not really affect the precipitation. Yes.
No, it does. It does impact it. So, but small impact from small island will be a lot less compared to the larger islands.
Okay. Yeah. Thank you.
So, in fact, this is a very interesting question about the small islands. So, there is a new initiative by the European Geophysical Union, EGU, I believe, and it's basically by the European Union, and they came up with 2 or 3 major topics for the next 3 years, and one of the topic was small islands in the tropics.
Okay.
Because those small islands are not represented in any of the models, so they want to find out what might be the impact of those small islands. Yeah. So if you have the data for like the size of the islands and their inundation, how much is being inundated, then we can actually try to look into the impact of those. But I do not have those data sets.
Yeah. Okay. Yeah. Thank you. So I think I agree with you that the couple model is really interesting because in Indonesia also we have like ITF, Indonesian True Flow, and if we remove, for example, Kalimantan and Sulawesi, the circulation is also different, changes. I mean, so
yeah, you cannot remove ITF.
That's correct.
Yeah, you cannot remove that. Yeah, that's. I think this is the next challenge, Prof. Adli. We can collaborate with the Prof. Kumar about that. Thank you very much.
Thank you.
Yeah.
Is there any? Oh, please. Sorry, Pallav. There are many. Your presentation interesting.
Thank you, Prof. Sorry, I'm not a meteorologist, I'm a microbiologist, but I'm interested with your presentation or talk. I just wonder, I just see on your presentation that the existence of land or islands can affect to the precipitations. If we remove or remove the islands, it can be affect to the rate or something of precipitation. But I just wonder what the most effect of that kinds of land. It's the just the solid mass of the land or the vegetations or the ecosystem? I mean, like we first know that in the global climate change, in the some changes in our ecosystems, like tropical forests change and into palm oil as example. It can affect to the precipitation phenomenon, or it just only the solid mass of island. I mean, it's like you have another specific detail of what the most impact to the precipitation of that kinds of land. Thank you.
Yeah, so that's a great question. So I think we actually did not look into the impact on ecology or forests in these cases. But you're right. I mean, if an island influences precipitation over other islands, then of course you'll have impact on ecological stuff and also, for example, tree mortality and all those. So one of the reasons why we did those land removal experiment is to basically convince the weather service in maritime continent that, let's say, we are all in Java, correct? So you are more focused in terms of getting the correct weather in Java. Now, if you are running a model to forecast the weather in Java and you are not getting the right result, so what I am arguing here is that the problem may not be over Java, but because you do not have good data from New Guinea and Sumatra, that you are actually getting bad rainfall over Java. So it's actually really important for Indonesia as a country to not just to improve your observational setup in one island, but you actually have to look into all other islands to actually improve forecasting over Java. So I think that was really the take-home message of our work, that observational network has to be expanded beyond Java to other islands as well.
Okay. Yeah. So it means that the complete coverage of the ecosystem can affect the precipitation rate.
Absolutely.
I mean, if the massive conversions the tropical forest into some kinds of palm oil fields, it could affect the changes of the precipitation in this area.
Yes. So there is a recent study from Taiwan, which actually looked into effect of deforestation, effect of deforestation on MJO. So it's the other way. They looked into how the land surface change may actually impact MJO. It's a very interesting study over the maritime continent. So basically, in one experiment, they have the normal land surface condition, and in another experiment, what they have is they have only grassland over the entire maritime continent. Okay. And then they looked into how it might actually influence MJO, and there is tremendous impact on it.
Okay.
Yeah.
Okay.
So it's a both way impact. Yeah.
Yeah. Thank you so much.
Yeah. I just add a bit. For practical use, we say that in our marine conservation area in Pangandaran, you see, from Professor Pallav simulation, we see also from the satellite, mostly the precipitation is higher along the coast, right? So it does mean that like a mangrove, whatever, living in the coast, very much affected by this. Yeah, that's for practical use of education. Is there any maybe student? Oh, okay, good. What is your name? Please tell.